Hey everyone, so in this video we'll be discussing Python sets. So let's get started. So first question is, what is a set? If you are familiar with list or tuple, set will make more sense. If you are not familiar with list or tuple, still you can understand what is a set if you follow the video. So let's get it started. A set is an unordered collection of unique elements. I'll explain this in more details. For now, just try to look at the definition. Sets are mutable. Now, the term mutable means you can add or remove elements from them. Set, they are defined using curly braces and contain various data types such as integers, strings, tuples, and even other sets. So let's look at an example which will give you more context. So first thing is set is unordered. What does that mean? So this means they do not maintain any specific order of elements like list or tuples. If you have used index numbers, you will know that you can use index number to access an element of a list or tuple, but you cannot do this in a set because set is unordered. So let's look at an example. If I create a set, let's call this set one. Okay, so sets, we need to use curly brace. So I'm going to use curly brace and say 1, 2, 3. So this is a set, and we cannot use index number, like we cannot say print set 1, 0. Okay, so this is not allowed. As you can see that this is already red. So if you have a list, then we can use index number. If you have a string, we can use index number. If we have a tuple, we can use index number, but set is an unordered list, so we cannot use index number. So that's the first thing. We cannot use index number on set. Okay, so this is not valid. Okay, so that's why we call that set is unordered. Okay, so we don't know the way we save the data 1, 2, 3, it will not maintain this order. Okay, so that's the first thing about set. Next thing about set is it only contains unique elements. In a list or tuple, you can add the same element twice or 3 times with no issues, but in a set, you can only have unique elements. So if I have 1, 2, 3, and if I try to add another item, let's say 3 again, it will give an error. So let's try to do that. So let's say if I say set 1 dot add 3. Okay, and then if I try to print it, you're not going to see the 3 twice. In a list, if you do this, you will see the 3 will show up twice, but in a set, it will not give you an error. It will just simply show you 1, 2, 3 with no changes. Okay, so you'll still see 1, 2, 3. You're not going to see that there is another 3. So this is why it's called only unique values are allowed. All right, that's the second thing about sets. Sets are mutable, meaning you can add or remove item from a set. I just showed you the example of adding. So if you do set 1 dot add, you can add item, but obviously it has to be a unique element. So if I do a 4, then it is allowed because we don't have 4 in this set. So you'll see 1, 2, 3, 4. So you can modify a set. You can also remove items from it. You can say set 1 dot remove. Let's say I want to remove the number 1. And after removing the number 1, I can print the set again. Okay, so if I click on run, so first you will see 1, 2, 3, 4 because I added 4 and then I removed 1 and then you can see 1 has been removed. Now, one more thing here is that if the element is not present, let's say you're trying to remove something that is not present in your set, it will raise a key error. But if you use the discard method, you will not see an error. Okay, so let's try to look at that. So for example, if I try to remove number 5, I don't even have number 5 in my set. I have only 1, 2, 3, 4, and now I'm trying to remove 5. So if I do this, it will give you an error. I'll give you a key error because I don't even have 5 in my set. Now, if you don't want to see an error, you can use the discard method. So instead of using remove, remove will give you a key error, but instead of doing this, I can do this. Instead, set one dot discard 5, and then I can print the set again. So if I do discard instead of remove, it will not give you a key error. It will just simply show you your set with 1, 2, 3, 4. If you try to discard 5, it doesn't exist. The only thing is that it's not going to give you an error. Okay, so that's about sets are mutable. Number 4, iterating over a set. So you can use a loop to go over all the elements of a set, just like a tuple or list. So what we can do is you can run a for loop. So for I in set 1, print I. So which will just go over all the elements of the set. So right now my set has 1, 2, 3, 4. So you will just see these numbers 1, 2, 3, 4. Okay, so you can iterate over a set. You can also do the same thing on a list or tuple. All right, so let's go to our next slide to discuss about the operation on sets. So to do this, I'm going to create 2 sets. Let's copy these 2 sets. Forget about all this. I'm gonna just delete all this and just paste these 2 new sets. So operations on sets. So sets support various mathematical operations such as union, intersection, difference, and symmetric difference. Now, if you're not familiar with these terms, that's okay. I will explain this in this video. So first one is a union of sets. So if you have these 2 sets, the union of 2 sets, set 1 and set 2, contains all the unique elements from both sets. So if you look at set 1 and set 2, you will notice that 4 and 5 are common for both sets. That means these 2 are not unique. The unique elements that you have 1, 2, 3, and 6, 7, 8. So these are unique elements, and that's called a union of sets. Okay, so you can see it says it returns a new set containing all the elements present in either set 1, set 2, or both. So if I do a union of sets, it will give you every element. Okay, but since 4 and 5 are duplicates, you will just see them once. You're not going to see them twice. Okay, just show you all the unique elements. So if 4 and 4 are common, you're not going to see them twice. It will just see them once. And the method that we're going to use is called dot union. So we can create a new set. We can call them union set. And then do that. So union set will be set 1 dot union set 2. And then you can print your union set. So if I click on run, you will see the new set, which contains all the unique elements from both sets. So 1, 2, 3 are unique, and then 6, 7, 8 are unique. So you're going to see all of them. So that's the union of set. I'll put a comment here. Union set. Okay. Next, we have intersection of sets. Now, what does that mean? So the intersection of two sets, set 1 and set 2, contains only the elements that are common to both sets. So if you look at these two sets, the only two common numbers are 4 and 5. These two are the unique elements. Okay, I'm sorry, not the unique, the common to both sets. So that means if you do an intersection of sets, you will get 4 and 5 only. Okay. So just like the way we did the union of sets, so I'm going to call them intersection set. So set 1 dot intersection set 2. And then I will print it. I will call this intersection set. Okay, so I will run this. And you will see 4 and 5 because these two are the common to both sets. All right, next we have difference between sets. The difference between two sets, set 1 and set 2, contains all the elements that are present in set 1 but not in set 2. It returns a new set containing elements that are present in set 1 but not present in set 2. Okay, so difference basically means you will check, okay, what are present in set 1 that are not present in set 2. So if you notice here, we do have 4 and 5 in set 1 and set 2, but we don't have 1, 2, 3 in set 2. That means if you do the difference between these sets, you will see 1, 2, 3. If you do set 1, different set 2, then you will see 1, 2, 3. But if you do set 2 dot different set 1, then you should see 6, 7, 8. Okay, so difference set. So let's do that. So let's call this difference set. So as I said, you can do this set 2 dot different set 1 or set 1 different set 2. It's up to you what you want to do. So we'll do set 1 difference set 2. And then let's print this. Difference set. Okay, since I did set 1 different set 2, it will show you what you have in set 1 and that are not in set 2. If I click on run, you'll see 1, 2, 3 because 1, 2, 3 they do not exist in set 2. Instead of this, you can do set 2 set 1. Okay, if you do the opposite, then you will see 6, 7, 8 because 6, 7, 8 they don't exist in set 1. Okay, so if I click on run, okay, you will see 6, 7, 8. And as I said, set is an unordered list, so you're not going to see 6, 7, 8. You may see 8, 6, 7 or 6, 7, 8 since all the elements are unordered. Okay, we have the last thing about set that we're going to go over today is symmetric difference between sets. Now, what does that mean? The symmetric difference between two sets, set 1 and set 2, contains all the elements that are present in only one of the sets, but not both. Okay, so again, when you have two sets, this one has 1, 2, 3, 4, 5, and set 2 has 4, 5, 6, 7, 8. If I am looking for the symmetric difference, what will happen is it will contain all the elements that are present in only one of the sets, but not both. Okay, and it will return a new set containing elements that are present in either set 1 or set 2, but not in both. Okay, let's see what happens if I run this piece of code. Okay, and let's print this. So I'm going to say print this versus symmetric difference. Okay, so that's our last thing I'm going to try. So if I click on run. Okay, so symmetric difference, you will see it prints 1, 2, 3, 6, 7, 8. So why do we see 1, 2, 3, and 6, 7, 8? Because 4 and 5 are common to both sets. Okay, so the symmetric difference in both sets, you can see 1, 2, 3, they exist in set 1, but they do not exist in set 2. So you'll get 1, 2, 3. Then if you look at set 2, 4, 5, they're common to both sets. But what are not common? That are 6, 7, 8. So that's why you're going to see 1, 2, 3, 6, 7, 8, and that are called the symmetric differences. Okay, so that's the last one. So again, contains all the elements that are present in only one of the sets, but not both. And it will return a new set containing elements that are present in either set 1 or set 2, but not in both. Okay, so we don't have 1, 2, 3 in both. We don't have 6, 7, 8 in both. So that's why we're seeing these. Okay, so that's all about sets, guys. I hope this makes sense. Thank you for watching. Bye.